I'm going to show you guys how to multiply some matrices with examples, and I'm going to show you how to find the inverse of a 2x2 matrix. I will also be giving you examples of this. You'll be using this bracket to find the inverse and multiplication, but you'll be using two brackets to find the multiplication. The brackets will have two different sets of letters to help you remember what goes where. For the inverse, you will just be using one single bracket. Okay, let's get started on the multiplication of a matrix. Now we're going to talk about multiplying matrices. Now there are two ways you can multiply a matrix. One is if it's by itself with a number on the outside of it. You would use normal distribution for this. 2 times A, 2 times B, 2 times C, and 2 times D. That is when you do not have another matrix over here and there's a number provided over here. This is the only way you can multiply a matrix by itself. Now let's talk about when there are two matrices, A, B, C, and D, E, F, G, and H. You have to multiply these two by itself. You're going to follow a very simple pattern for this. For where each row and column meet is where what you multiply will be placed. So, you will follow the A times E, B times G. Think of it as taking this column and placing it on top of it to where E and G would be there. You would multiply those two to where they are even. So, you take A times E plus B times G, B times G, and that will equal the top left number for your matrix. Then, for this top right, you will do A times F plus B times H. This will give you the top right because they intersect here. This row intersects with this column at this F. This AB intersects with this top left E at this E. So that is why they go there. C times E plus D times G goes in the bottom left because the C, D intersects with the E, G at this bottom G. Then you're going to do the C times F plus D times H because yet again they meet here and here at this bottom H. Once you have these letters figured out, you only have to solve. These will once be numbers and you just plug them in as so. They can be negative, fraction, decimals, and obviously positive numbers. It can be pretty much anything put in here. This too has nothing to do with this and this, but it can sometimes appear here, and then if you first multiply the 2 times A, 2 times B, 2 times C, 2 times D, and then you do this process of multiplying it. Let's look at an example of this and with real numbers and not. For example 1, we're going to be using a simple 2 by 2 matrix, meaning each row has 2, each column has 2. 1, 2, 1, 2, as such. So if we're following the same pattern as I've shown before, the A, B, C, D, E, F, G, H, then you will know that each number, which will be 3 times 5 plus 2 times negative 1, will go here, and such forth. Each one will go to where it intersects. Before I show you my work and my answer, try working it out on your own. Okay, I hope you got the answer I got. We have to just walk through and do the exact same pattern I've shown before. 3 times 5 over here where it intersects goes right here, plus 2 times negative 1, which goes right here. You just have to add them together and they intersect at this 5. That is how you know where the placement is if you cannot remember any other way. You do this for everything else. So, negative 4 times negative 3 plus negative 2 times 7. That goes right here because of the way they intersect in this bottom right corner. You do the exact same thing for the other two spots. For this spot, you look and see where and what connects to it. So you do negative 4 times 5 plus negative 2 times negative 1, which goes right there. Then you look for which spot was working. Now I'm going to show you another equation for multiplication, but this will show you what you can and cannot do. When multiplying, there are boundaries you have to stay in. For an example, what we did up here was a 2 by 2. 2 by 2 times a 2 by 2. When we move down here and look at the first part of example 2, you see I wrote an X. You cannot do this. See, there are 2 rows and there are 2 columns, yes, but you have to have 2 rows and 2 other rows, not 3. There is no way you can multiply this. But if you have 2 rows and 2 rows, you can multiply them just as well. You can also have 3 rows, 4 rows times 3 rows and 4 rows, and will work just as well. You can do this with more than just 2 rows. There's no boundary of what you can do this, it's just a lot more work, and we're just sticking with 2 by 2s and 2 by 3s. Correction, 3 by 2s, I said it wrong, whoops. So, this is the multiplication of matrices. Pretty much everything you need to know. As I said earlier, there can be a number outside of here, so if there was a 2 here, you just multiply 2 times 3, 2 times 2, 2 times -4, 2 times -2. Then with the corresponding answer of that, you then multiply this matrix the same way as you would multiply this, just with your new numbers in these locations. Let's move on to finding the inverse of a 2 by 2 matrix. When finding the inverse, you will need to use a calculator. It is very helpful. So let's start with the basic equation of an inverse. So by now, you should have solved or have been given a matrix, A, B, C, and D. This is what you will start with. So, when finding the inverse, it is important that you use data, which you will calculate in your calculator, which I will show you in a few moments, and your normal matrix, which we will change into this. I will explain how and what you do in a moment. But make sure you have a calculator to do this. I repeat, have a calculator. So before we go into the calculator things, let's start with how you get this, because I know this looks confusing, but it's not. So pretty much, you take the A and the D and you switch them. So the A goes to where the D is, and the D goes to where the A was. Then you take the B and the C, and you simply make them negative. And if they're positive, you turn them negative, and if they're negative, you turn them positive. So if this was a -2, it turned into a positive 2. If this was a 2, it turned into a -2. Makes sense? Makes money. So now that we have our beautiful new equation to multiply by, you now have to figure out how to make det. Or I call it deta because I see A. So, A is this equation. This equation will be A or B if you're using another matrix equation, but just call it A for now, and I'll show you how to find det in your calculator. Okay, so if you cannot see this, I'm sorry. But right now, I'm going to show you how to program a matrix into your calculator. You hit second, you hit this x to the -1, and you go over to edit. You hit enter, and say we're doing a 2 by 2 matrix, so you just type in 2, enter 2. See, our matrix is 1, 2, 3, 4. So you type in, move this up a little bit, 1, enter, 2, enter, 3, enter, 4, enter. And now you have your A matrix. So you go and you hit quit, which is second mode. And now let's say you have to find the det. This is very simple. You just go to x, -1. You see our existing equation is already here, our 2 by 2 we just plugged in. You go to math, and it's the first option that you can choose. You can enter or you can hit 1, it's up to you. You go to det, and you go back here to second, x, -1, and you hit enter, or you can hit 1 or A. Then you just hit enter. That equals -2. So, now let me show you what you do with this -2. Fun fact, this det equals determinant. I was just blanking on words earlier, so please ignore that, but yeah, that's the So anyways, you take this determinant times A, which is what we just did in our calculator, and you have to put it under 1 in a fraction. Very simple. Then you take our matrix that we used before, switch it, change it, rearrange it, and put it in this format. I will show you the exact equation I just showed you in my calculator, what it turns out to be. Okay, so I wrote it down and worked it out. Our 1, 2, 3, 4 turned into 4, -2, -3, and -1. Remember, you just have to switch these two and make these two negative, or if they say this was -2, that would turn into +2. You just change what it was. So, we took 1 over -2, which was our determinant, and you multiply by this is what you did, and you put it right here. So it's 4, -2, -3, and 1. Then you plug it in, or if you want to, you can work it out by hand, but I prefer plugging it in. And then you get this answer, which is -0.5, -1, -1.5, and -2. this will be your inverse of this equation or matrix. Sometimes this does not work and you will have an error or a 0 in the count. This is an example of a matrix where you cannot find the inverse. This is where the determinant of A, which in this case is this equation / matrix, equals 0. When it equals 0, you cannot find the inverse. When you plug this in, it will not turn out right. You will not get this beautiful little matrix because you have to do 1 over 0. 1 divided by 0 is 0, obviously, so it's pretty much going to be multiplying this times itself, or just that, which will not be correct. So you cannot find the inverse. So if you ever plug it in and you get a 0, it is impossible and it's just an error. So if the answer is impossible, it's a 0, the answer is impossible. Anyways, I hope you learned how to multiply a matrix and find its inverse. I surely learned never to become a YouTuber, so it's a win-win situation for both of us.